So the topics for today are variables, types, and string formatting. But before we do that, um, I'm going to give you a little bit more information about Python. Okay. So first of all, Python came from another language, another computer programming language. A lot of computer programming languages are derivatives of previous languages. For example, the C language gave birth to C++ and C++ and C Sharp. Java gave birth to JavaScript, and Python's not really any different. This guy, Guido van Rossum, was a Dutch scientist who was working in the late 1980s. Now, in that time period, there weren't people who walked around calling themselves computer scientists because computer science as a discipline wasn't really its own thing yet. People used computers for other things. They use it to study math, they use it to study science, and Guido van Rossum was no different. He was a scientist, and he was using a language called ABC. And as he got into his work, he found himself continually wishing that ABC had certain capabilities that it just didn't have. Like, my life would be so much easier if there was just a function for this thing. And like any good nerd would do, he finally hit that point where he was so frustrated that he just decided, I'm going to make my own programming languages. So, just like we do on our Saturday time, we're sitting around and I'm just going to spawn a computer programming language. Little did he know that it would become the most popular programming language on the planet, but he started building Python for his own use. And so after a few years, or after almost a decade, it was publicly released widely, but he used it for quite a while before that. And he actually named it Python, not after his love of snakes, but after his appreciation for one of the greatest films of all time, Monty Python and the Search for the Holy Grail. So that is the true story of where Python got its name. If you haven't seen it, you'll either love it or you'll hate it. There's not really in between there. It's that dry British humor, and people don't tend to feel in the middle about it. Later on, some Python user groups sort of came up with these ideas or these ideals, as it were, about Python, but they're sort of things to live by as you're programming in Python code. Beautiful is better than ugly. Not in the general sense, like out in the world. Of course, beautiful is better than ugly, but in terms of code, Python is built to be a nice looking, clean looking language. If you've seen C, or if, heaven forbid, you've seen assembly code, it's not pretty. It's just there. It's functional, let's just say. Sturdy even. But Python is meant to be good looking code. Explicit is better than implicit. In other words, don't make assumptions about variable names or data types or things like that. Simple is better than complex. Complex is better than complicated. So simple is better than complex. Complex is better than complicated refers to the idea. I'm sure you've heard the KISS principle, keep it simple, stupid. That's sort of the same idea. But in Python, there is three layers there. Simple, if you can do something simply, that's the ideal. If you can't do something simply, then you can do it in a complex way. But you always want to try and avoid complicated. Complicated is sort of like killing a housefly with a hand grenade, right? It's too much, it's overkill, you wasted time, you wasted code. Flat is better than nested. This is going to make more sense as we get into the code structure. Sparse is better than dense. In other words, leave white space. You will see me, when I'm coding, often skip lines, leave space, spread things out. That's better than a block of code with no spaces in it. Why? Because it's easier to read, it's easier to process. And so the emphasis on Python is like, let's do this, let's do it in a simple way, and let's make our code easy to read. So we can share it, so we can explain it, so we can understand it ourselves. So sparse is better than dense. Readability counts, kind of the same idea. And there's always an exception, right? But most special cases aren't special enough to break the rules. So that is the Zen of Python. They're not really rules, they're just sort of things that we try to keep in mind as we're coding. So what's so great about Python? Because obviously Python is very popular. In fact, it's the most popular language in the world. And it became the most popular language in the world around 2017, late 2017. And it has not looked back. In fact, this chart ends in 2018, but what we'll see in just a minute is that it continued to grow beyond that. Python is easy to learn. It uses more natural language. What does that mean? It means you can sit down and read code and it kind of makes sense even if you don't understand code, because it uses words that make sense to you. It's versatile. It's extensible, meaning if you want Python to do something that it doesn't do, you can actually write extensions to Python that allow it to do other things. And most of all, due to its popularity, it has a great user community, which means there's a lot of people out there who know how to do things, who have encountered the same problem before. And if you get involved in that user community, it's really kind of cool because you can ask questions and get information as you need to. This index, the TIOBE index, is an index of software usage for coding. And here is its ranking of the most popular languages as of January 2004. Or 2005, sorry. It does a comparison with where those languages were in 2004. Python, number one, and it was number one last year. But you can see 23% of the ratings, and this is out of 100, by the way. So a quarter of the people say Python is my primary language. Come on ahead, sit down. And then C++ is the second most popular language. It was number 3 a year ago. And you can see it's less than half of that. Java is slightly behind C++. Then we have C and C# and JavaScript. And so that's a big deal. And you can see here, the C language here, this is what was used to, that's what's used to create operating systems. So it's a big deal. Here's a chart of Python's growth over time. Okay, and you can see that today, that's its ranking, and the second place ranking is all the way down here. So Python is massively popular, and it continues to grow. It continues to grow in popularity. So that's a good thing for us because it means there are lots and lots of resources. So where is Python used out in the wild? If you think Python is a niche language or just used in certain places, you're kind of wrong. These are all the companies. These are all companies that use Python. They're not all of the companies because Microsoft isn't on here, and I know for a fact Microsoft uses Python in production. But there are so many companies, and you'll see some big ones: Google, YouTube, Amazon. You know, there are some big ones here. But these are all companies that actually use Python in production situations. So the jobs for Python programmers are many. Here are just a few things you can do with Python: web development, data science, machine learning and artificial intelligence, robotics, game development, scientific computing, databases, and embedded systems and Internet of Things. And that's just a few. Now, one thing that it's important to note about Python is that it's a high-level language. What this means, and it's not a ranking, it doesn't mean that Python is a better language than, say, Java or C++ or whatever. What it means is that Python requires or relies on a translator to talk to the computer. Another language like C++, if I write a program in C++, I use what's called a compiler. And that when I finish writing my code, I run it through the compiler, and the compiler changes my code into machine-readable code that the machine can directly understand. And then when I run that program, and on Windows, it's like an executable file, an exe file. That's what that means. It's a compiled program that can run. I can't open an executable file and read the code anymore because it's been translated to code that the computer can understand. Python, on the other hand, is an interpreted language. And so it uses, and I told you this last time, we download Python in addition to PyCharm. PyCharm is what we use to write code. Python is what we use to run the code. Python is the interpreter. And just like if I travel to a foreign country and I rely on an interpreter to help me have conversations with the people there, Python programs or Python scripts rely on the Python interpreter to communicate with the computer in a language the computer can understand. That makes it easier for us as programmers because we don't have to compile our programs. We just write the code, test it, write the code, test it. It's a very quick cycle for us. We don't have to deal with that. The downside, the sacrifice that we make in using an interpreter is that just like if I went to a foreign country and I'm speaking to somebody back and forth with an interpreter, it takes a little bit longer, right? Because I have to say something, then the interpreter says it to them, then they say something back to the interpreter speaks back to me. It's the exact same way. When I run a Python script, the Python interpreter uses that script to talk back and forth to the computer, and then it produces an output. So there's a lot of back and forth here that goes on. And that ultimately means that Python programs run a little bit slower. Now, on my computer, when I run a Python program, it will happen pretty much instantaneously. And the reason for that is because the code I'm writing is really small and I'm just one user running at one time. You won't probably have many situations in your life where you're having to worry about the speed of your Python code. However, let's say you get a job after you finish up your education working for Google. And you have a choice to create a program that's running outward facing on Google's production servers, which means it might be getting hundreds of thousands of hits, or that program might be run hundreds of thousands of times a minute. The difference between a Python program running in that situation and a compiled program running in that situation, number one, the Python program might just crash their servers because it's that much slower. Because if you're running at times 100,000 a minute, that's different, right? But here's the interesting thing that you probably haven't even thought about. It's not just about the speed of the program, because at that level of scale, you actually get into energy costs. And that difference between your Python program and a compiled C++ program, let's say, could end up costing Google millions of dollars in electricity costs over the course of a year, just in the difference code. So that's the scale we're talking about, where it really starts to matter. Now, if you're writing a desktop program for people to run on their computers, most of the time, unless that's doing some kind of heavy-duty processing, Python is going to be just fine for that. Nobody will notice it. Nobody will say, well, this kind of runs slow. Nah, you won't even notice it. And in fact, when we get to the game design unit, we actually have to build in code into the game to slow the computer down, because Python will run that code so quickly if we don't, that the game will end before you can even move your character on the screen. So we have to sometimes moderate how fast Python can run. So it's all relative to what you're doing. But that is why you might hear of Python as a high-level code or a high-level language.